Okay, so still about pyramid, but this one we're talking about the very specific one, just about truncated pyramid, which is basically a pyramid that has been removed, truncated. A square-based pyramid, given the picture, has a base of side 8 centimeter and a height, the height of the pyramid, it means 12 centimeter, and then a square-based pyramid of height 6 centimeter is removed by cutting parallel to the base. So then see this one, so it's cut, so then it's gone already basically. In some cases they only give you they don't even give you this part, so then you don't even know like what is that. So then this kind of idea is also there in the first chunk. If you remember, it's in the surface area as well. So let's see. Because of that, because we are to find the volume of the truncated pyramid. How do we find the volume of this? So volume should be the volume of the initial pyramid, which is everything before it is cut, and then minus the volume of the remove. Let's say remove. Okay, like this. So 6 centimeter is the height of the smaller pyramid that is actually removed. So then that means the whole pyramid, because it's a 12, right? So everything is 12, and then this is 6, and then this remaining part will be 6. That's something that we could know. And this is because it's a square base, so then we know the area is just 8 times 8. So the volume of the initial, that means it's a 1/3 times 8 squared times 12, right? But when we are looking over, how do we find the volume of the removed pyramid? We know the height, which is 6, but we don't know the base area. So what should we do? So because of this, I think very similar with the surface area problems like last time, what we can do is we can use once again similarity or similar figures in the case of this. So you see the bottom part is 8 centimeter, and then if we put the cross section, we see the pyramid from like the front part or the side, so then we'll be getting like this. Let's say this is cut, so everything is 12 centimeter, so this part is 6 centimeter and this is 8 centimeter, right? Let me just erase the centimeter. So 12, 6, 8. So how can we find this? So let's say we name it x. So the way it's x over 8 similarity equals to 6 over 12, or it means a half. So the x must be a 4. Okay. So knowing the ratio, knowing the what is it, like the connection between the smaller triangle, or which is actually the smaller pyramid, and the bigger pyramid, that could help us understanding this idea, which is actually finding the volume of the truncated pyramid. You can use similar figures as well if you want, but if not, then this one can be done as well. So this 1/3 times 4 squared times 6, because we get the 4 from here, so that we would be getting 64 times 4, it's a 256 minus 32, which is 224 centimeter cube. So you might want to see this again. The idea is here, and then it's best because it's visualized already, then it's best that you could also visualize this thing, because it helps even for me to understand the context and then what we can do next. Okay, that's it. So I'll be moving for the last part, not really last part, but the cone and sphere, which is probably in some cases it's more challenging, but let's see.